Welcome to Mysterious Universe, the place where curiosity leads the way, and the wonders of space come alive. Whether you're here for the science, the mysteries, or just to ask, what if, you're in the right place. Thank you for joining us. We're glad you're here. If you love mind-blowing discoveries, cosmic puzzles, and ideas that challenge what we think we know, hit that subscribe button, tap the notification bell, and be part of a growing community that dares to explore the unknown. We post weekly videos that take you deeper into the universe, so don't miss a single journey. Today's episode is called Secrets Scientists Just Found on Mars, the Truth Beneath the Surface. And what you're about to discover might completely change the way you see the red planet. Imagine this. The Martian ground trembles beneath your feet. Not because of volcanic heat, not because of shifting tectonic plates, but because something from outer space just slammed into the planet and shook it to its core. That's right, Mars is quaking. But the source of those tremors isn't what we thought. Recent data has revealed a shocking truth. Some Marsquakes are caused not by internal forces, but by meteoroid impacts from space. And what they're uncovering beneath the surface is even more unsettling. Using a combination of artificial intelligence and seismic data from NASA's InSight lander, scientists have discovered something strange and unprecedented. A seismic highway beneath the surface of Mars. This mysterious path allows shockwaves from meteorite strikes to travel deeper and farther through the planet than anyone ever expected. And that's just the beginning. These findings are now helping scientists solve one of the greatest Martian puzzles of all time. Why does Mars appear split in two, with one half thicker, higher, and hotter than the other? Is this evidence of ancient tectonic activity? Is Mars still geologically alive? Or is there something deeper, darker, waiting beneath its rust-colored crust? Stay with us, because in the next few minutes, we're going to take you on a journey below the Martian surface. You'll learn how this seismic mystery was uncovered, what it means for the future of Mars exploration, and how it could reveal clues not only about life on Mars, but about the future of our own planet. This isn't science fiction. This is science, catching up to imagination. Let's begin. Marsquakes were once believed to come from within, a quiet planet contracting and cracking as it cools. But recent discoveries flipped that idea on its head. NASA's InSight lander recorded over 1.300 Marsquakes. These signals, when compared with impact craters seen from orbit, revealed something astonishing. Some Marsquakes are triggered by space, not internal forces. Meteoroids crashing into Mars are sending shockwaves deep into the planet's crust and mantle. Scientists started noticing these tremors occurred shortly after new craters formed, sometimes more than 1.000 miles away. One standout case? A 71-foot wide impact in Cerberus fossae matched a quake InSight picked up from incredibly far away. This meant the impact energy didn't just ripple briefly, it traveled with force and direction. These waves weren't scattered, they were focused, as if guided by underground structures and organized, invisible pathway. That led to a bold idea. Mars has seismic highways, deep channels beneath the surface where seismic energy can travel farther and faster than expected. This discovery means we've underestimated the way Mars responds to external forces. The planet is still dynamic, but in ways we hadn't imagined. On Mars, the sky isn't just empty, it's dangerous. Scientists have found Mars is bombarded by meteoroids 2.5 times more often than expected. These impacts aren't just surface events, they're deep geological disturbances. By comparing InSight's Marsquake data with before and after orbital images, researchers linked 49 new impact craters to recorded seismic activity. Among them, the Cerberus fossae crater shook the entire region, despite forming more than 1,000 miles away. Why do these impacts travel so far underground? Because Mars' crust is dry, hard, and brittle, perfect for carrying seismic energy. Unlike Earth's damp, layered crust that muffles vibration, Mars transmits shock efficiently. More shockingly, these impacts don't just radiate outward, they follow distinct paths through the mantle. These routes became known as seismic highways. That means meteoroid strikes are more than threats, they're tools. Tools to peer into Mars' interior. Much like how doctors use ultrasounds, every impact reveals more about what's beneath. But it also raises concern. If a small impact can shake Mars this much, what happens with a larger one? Are we prepared for what those deeper quakes could awaken? A seismic highway. It sounds like science fiction, but it's real, and it's buried beneath Mars. InSight's seismic readings showed something odd. Energy from impacts didn't disperse like waves in water. Instead, it followed specific, repeatable paths, sometimes bypassing the crust entirely. These highways act like nerve pathways inside the planet, transmitting signals with speed and accuracy. They're likely formed through billions of years of cooling and fracture. Dry, dense rock helps sustain the wave's strength over long distances. This suggests Mars' interior isn't uniform, it's layered in a complex way. Perhaps still retaining thermal activity or even pockets of semi-molten material. On Earth, similar structures exist only in limited zones. Mars, however, may be crisscrossed by these pathways, especially near Cerberus Fossae, a region still rattling with tremors. These seismic highways may be remnants from a time when Mars moved like Earth, when tectonics were alive. They may be the last functioning channels in a system that once shifted crust, shaped valleys, and spewed magma. And now, they're the last way the red planet speaks. From orbit, Mars looks divided. The northern hemisphere is flat, smooth, and low. The southern half is rugged, elevated, and heavily cratered. This dramatic contrast is called the Martian dichotomy, a mystery that has puzzled scientists for decades. Why is one half of Mars 3 miles higher than the other? Why is the crust in the south twice as thick? Two main theories emerged. One suggests internal tectonic uplift. The other proposes a colossal impact, a collision with a moon-sized object. But thanks to data from InSight, we may finally have a clue. InSight was placed near the transition zone between the hemispheres. It recorded seismic waves traveling differently through the north and south. In the southern highlands, waves lost energy quickly, suggesting a hotter, less dense mantle. Meanwhile, the north showed colder, more stable characteristics. This thermal contrast implies that internal planetary forces, not just an impact, likely shaped the split. Mars may have once had tectonic activity, rising mantle beneath the south, sinking mantle in the north. And as that activity slowed, it left the planet frozen mid-transformation, one side lifted, the other suppressed. This imbalance might also explain why regions like Cerberus Fossae are still active. Fractures created by ancient tectonics continue to release energy. Mars didn't crack overnight. Its crust reflects billions of years of motion, warping, and settling. But the division remains, a planet with two distinct pasts, joined in a single, silent world. Did Mars once move like Earth? Mounting evidence suggests it might have. Scientists now believe Mars may have once hosted tectonic plates, sections of crust that shifted, collided, and reshaped the planet's surface. Structures like the Valles Marineris, the largest canyon in the solar system, may be remnants of tectonic rifting. Fractures like Cerberus Fossae resemble fault lines. And seismic irregularities hint at a layered interior, fractured by ancient forces. What stopped this motion? Mars is smaller than Earth. It cools faster. Over time, its molten mantle lost energy. The crust thickened and hardened into a stagnant lid, freezing the once mobile planet. Yet signs of life remain, not biological life, but geological. Marsquakes still rattle tectonic scars. Magnetic anomalies in rocks point to a long-lost magnetic field, powered by a once active core. This ancient magnetic field could have protected an early atmosphere, even liquid water. Its disappearance stripped Mars bare, vulnerable to radiation. wind, and desolation. But that silence might not be absolute. The fact that we still detect tremors means something still stirs beneath the surface. Perhaps magma remains in isolated pockets. Perhaps the past is not finished echoing. And if Mars once had tectonic motion, volcanic heat, and water, could it have also harbored life? We often speak of Mars as a dead world, but the evidence tells another story. In 2022, NASA's InSight lander recorded the strongest Marsquake to date, magnitude 4.7. It came from deep underground, with no surface impact to explain it. That means Mars still has internal energy, enough to shift, crack, and release pressure. It may be dormant, but it's not dead. Some scientists believe this activity comes from slow core cooling. Others think isolated chambers of magma may still exist, locked under thick crust. If disturbed by impact or tectonic stress, they could erupt again. And there's more. In 2020, radar data revealed liquid water beneath the southern ice cap. It's likely salty and deep, but still liquid. On Earth, such environments host microbial life. Could Mars do the same? With internal heat, ancient tectonics, and subglacial water, Mars checks off several key conditions for habitability. No one's claiming life exists there now. But if life ever did arise, underground is the most likely place it survived. Mars may be a sleeping planet, but it murmurs. It remembers. Each quake, each vibration, each distant echo beneath the rusted surface is a message. The planet hasn't gone silent. It's whispering. And we're just starting to listen. For centuries, Mars has been a symbol of war, of wonder, of distant mystery. We sent rovers, satellites, landers. We mapped its canyons, touched its soil, listened to its ground. And slowly, quietly, it began to answer us. Not with words, but with vibrations, with tremors, with scars buried deep beneath its rust-colored skin. And what we've learned is humbling. Because Mars isn't just a rock floating through the void. It's a planet with a past, a violent, moving, living past. A world that once cracked, erupted, and may have even protected life beneath its frozen crust. It bears the silence of a sleeping giant, but carries within it the echoes of something that once thrived and might, just might, still breathe. This isn't just about Mars. It's about how we look at silence, how we interpret stillness, how we listen not only to what's loud, but to what's hidden, deep, and easily missed. The universe is speaking to us, not in explosions, but in whispers. And those whispers matter. They challenge our assumptions. They teach us humility. They remind us that even the quietest places can hold the loudest truths. So when we ask, is Mars still alive? We're really asking something deeper. Can a world die if it still has motion? Can something end if it still echoes? And more importantly, can we, as explorers, truly listen? Because space isn't just cold and distant. It's full of stories, of energy, of memory. And in every crater, every quake, every silent shift on Mars, there's a story waiting to be told. At Mysterious Universe, we're here to tell those stories. To dig deeper, to wonder louder, to never stop asking, what if? If this journey moved you, if it stirred a sense of awe, a spark of curiosity, don't let it end here. Subscribe to the channel. Like this video to help others discover it. Share it with someone who still believes that the universe has secrets worth discovering. And in the comments, tell us. What do you think is still waiting beneath the surface of Mars? Because the more we ask, the more we search, the closer we come to something incredible. Mars still has more to say. And together, we're going to hear it. This is Mysterious Universe. Thank you for watching. And as always, keep wondering, keep listening, and never stop looking up.